Good morning, students. Myself, Dr. Eustace Russell, working as an assistant professor at Sri Muthukumaran Institute of Technology, the Department of Mechatronics Engineering. Today, we are going to see one important as well as interesting topic subject called Robot Dynamics and Control. The subject code is RA3601, which is coming under the semester of 6th semester under the regulation of 2021. Now we will see the topics one by one. Now, what is the course objective of this subject? The major course objective, why you are studying this course? Mainly the robotics students are studying this course, robotics and automation students are studying in this subject. The year, this third year, they are studying this subject. What are the major objectives means? To learn and understand generalized coordinates, that is Jacobian matrix, mass distribution and other fundamental equation, as well as to understand Lagrangian and Hamiltonian mechanics, to understand non-linearities in control system, to understand various force control statistics, to understand various concepts in linearizing as non-linear signal. These are the objectives why students are studying this course means these are the various things they are going to understand in this course. This slide give a glimpse about unit 1, that is robot force models. That is various topic here it is shown here. That is generalized coordinates, generalized forces, equation of motion, static forces in manipulators, Jacobian matrix, Jacobian in the force domain, Cartesian transformation of velocity and static forces, acceleration of a rigid body, mass distribution, non-rigid body effects, Newton's equation, Euler equation and Lagrangian equation. So mostly this subject, the students will study the derivation part mostly in this. When compared to theoretical part, the student must know the various equations. Well, the motion of the robot, while we are considering the motion, what are the various equations and Euler's equation we have to consider in that. The first unit, majority of the concept covers the derivation part, that is robot force models. Today we are going to few topics under unit 1. Before that, I want to tell about robot accessories, why it is needed, what is the purpose of accessories for a robot. That we will see one by one. The first thing is, robot is a intelligent system that interacts with the physical environment through sensors and effectors. Everywhere sensors are there. Without sensor, nothing is possible. To operate this, sensor is very, very important. As a human being, we have a sense. When you are touching on object, we can feel. When you are touching a hot things, we can feel how much temperature it is. So our body have a sensation like that. The robot should operate through sensors and effectors. So the important thing is, it consists of the following elements which are integrated to form a whole, that is manipulator, rover, other name is called rover. This is the main body of the robot and it consists of links, joints and structural elements of the robot. That is, it consists of various links, various joints also combined here. What is the end effector? That is, generally handles the objects, makes connection to other machines or perform the required task. So that is like, as a human we have a hand to handle the objects. Likewise in the robot we will tell us it is an end effector. It is vary in size and complexity from an end effector on this space. That is, a gripper also will be seen in the end effector concept. Now it is followed by actuators, sensors and control. What is actuators? Actuators are the muscles of manipulators common types of actuators are servo motors, stepper motors, and pneumatic cylinders. These are coming under actuators. Then what is sensor? Sensor are used to collect information about the internal state of the robot or to communicate with the outside environment. That is the main purpose of sensor. So it will sense the object, any obstacle are there. It will identify and give the feedback about that. Robots are often equipped with external sensory devices such as vision system, touch and tidal sensors, etc., which helps to communicate with the environment. Various sensors also we will study in the upcoming units. Then controller. Controller which means what? Means it receives the data from the computer, controls the motion of the actuator and coordinates this motion with the sensory feedback. So based on the feedback only, the control will operate. This is open system, closed system. Whenever the sensor is operating, we can control it based on the feedback it is receiving. Now, the first topic of the unit 1, that is generalized coordinates. We will see one by one. That is Cartesian coordinates, that is rectangular gantry, that is 3P it is given. Now, before going through this, I want to tell us what is 3P. That is prosthetic joints. Prosthetic joints. Before going into the topic, I want to tell about prosthetic topic joints are mentioned by P, alphabet P. That is prosthetic motion is nothing but giving a linear motion. The particle that is moving under linear, that is rectilinear one, that are called prosthetic motion. Then R is revolute. So whenever there is a revolution is there, we can tell it is a revolute joint will be there. In this first type, in the left hand side, we have mentioned about that is rectangular gantry. Here we can see clearly, you can see in the sketch, along x-axis also we have a movement, along y-axis also we have a movement, along z-axis also we have a movement. Finally, it will form a rectangular path. So whenever it is moving, it is showing a path of a rectangular box. That's why it is called as rectangular gantry. So that is one type of coordinate we have seen here. Then right hand side we have mentioned about cylindrical coordinate system. What is that? It is having two prismatic joints and one revolute joint. That is clearly mentioned over here. That is R2P. 2P stands for what? Two prismatic joints. That is two linear motion will be implemented here. One is that you can see in the sketch. Both the direction we can see. We have a linear motion. That is L, it is denoted, and here O is also denoted. Both will have a linear motion. And what is T? Alphabet T. We have a revolute motion. We have a revolute motion. Now it is spherical joint. Spherical joint, what is that? So while moving, it will form a spherical shape. We can see a path of the spherical. As I told in the first type of the gantry, what we got, that is a rectangular box type of path we have got. Here we can see a spherical type of the shape. What is that? Having one radial displacement and two independent angular displacement. One radial displacement, that is important, and two independent. We can see where is the two independent means we can see both two are, one is in the lower and another one is the top. We have a revolution. We have a revolute joint over there, and the linear is denoted as L. We have a linear motion, that is called prosthetic motion. Here in this articulated, that is 3R it is mentioned. What is that 3R? That is 3 revolution will be happening over here, where it is that 2R having a movement of revolution, and another one also, the end also will be get rotated. 3 part we are having in the 3 joints, we are getting a revolute motion. That's why it's called as articulated coordinate system. That is in this no prosthetic revolution. So there is no prosthetic motion here. All are under revolute motion. Now what is the next type means? SCARA. What is the full form of that? Selective Compliance Assembly Robot Arm. short form we can tell SCARA, SCARA. What is that 2R, 1P? 2 revolute motion and 1 prosthetic motion. Clearly it is mentioned. They have 2 revolute joints. They are parallel and allow the robot to move in a horizontal plane plus an additional prosthetic joint that moves vertically. So various application it is also having. The various we have seen so many coordinate system. Various system having various application. Whenever it is needed, mostly for loading, unloading, this type of robot will be utilized, as well as transportation of the goods from one place to another place, keeping the goods or products as a palletizing. Palletizing means keeping the jobs in a platform before shipping process. That is palletizing. In some of the robot for painting works, welding, mostly welding work, this type of spherical also we will implement it over here. Some various application, especially transportation, mostly in assembly work, this type of SCARA will be implemented. Assembly work, SCARA, the most application in the industrial areas, they are utilizing this type of coordinate system. We can see the glimpse of that pictures, what you have seen already. As I told, that is the first one is a Cartesian, second one is cylindrical, and the third one is spherical, articulated, and SCARA. This already we have seen. Then work envelope concept. What is that work envelope concept means? That is a workspace under which area the robot is going to work. The working environment. For example, if you are working in one place, the surrounding area we will call it as a working area or working environment. Like that, robot under which area it is going to limit of that area. Under what area the robot can work, that will be called as workspace. That is depending upon the configuration and the size of the links and the wrist joints, the robot can reach a collection of points called a workspace. That is the limit up to where the robot will travel to do the job in a particular limit. That limit only it can work. It can't go beyond that limit. Alternately, workspace may be defined by moving each joint through its range of motions and combining all space it can reach and separating what space it cannot reach. Now wrist, like our hand wrist, here is the main component of a robot. What are the various function? Rolling, pitch up and down, and yaw, various things. Yaw. Roll means for revolution purpose we can use this. Pitch, up and down motion will be there. Just like when you are moving a hand like this, it is called as pitch. Yaw. So like that, in this direction. Yaw. Roll, totally it is rotating. If you want to drive screw drive anything, we can give a movement in this direction, clockwise, anti-clockwise. So that is the rolling one. The yaw means it will be moving like this, in this direction. Yaw, left-right rotation. Anywhere we can move. End effector is mounted on the rest. That is the, I already told, is the type of gripper. The end effector is the final output what you are getting in the final. It won't be considered as not as a link. It is attached to that link and it will be considered as one frame only. So we can't tell the end effector is a separate link. Okay. So generalized forces. This is the next topic of the syllabus. That is the various forces we are going to see. That is the introduction of generalized forces. As you already seen in the engineering mechanics concept, we have the students might have studied robotics and automation engineering students might have studied engineering mechanics. That they have studied about various work energy force, why it is needed, what are the various forces, impact of the forces in the physical behavior of the bodies. The same thing here also we are going to have a glimpse about the revision, that is work, energy and force are the fundamental concept in physics. And understanding their definition and formulas help explain the relationship. And also for analyzing motion and mechanical systems. Now work is nothing but force into distance. Everybody knows this formula. Work is nothing but energy transferred when the force causes displacement. Whenever we are moving one object to one place to another place with the help of some work only, work will be added. Then only we can get some displacement, right? That is called W equal to F into D. When you are considering the angle at theta, then we have to consider W equal to FD cos theta. Then unit of work is nothing but joule, that is Newton meter. Work can also be done by magnetic forces, gas compression, and shaft rotation. These are termed as work. Unit is joule. Joule is nothing but Newton meter. Here another energy. Second type of the centralized forces are energy. Energy is the capacity or ability to do work. Law of conservation of energy. This physics you might have studied. Energy cannot be created or destroyed. It can only change from one form to another form. Unit is joule. As well as we have studied about kinetic energy, that is half mv square. We have to consider mass into velocity. And potential energy considering the height. Whenever you are dropping a stone or a ball from on top of the tower, we have to the energy that will be stored as mg height. The kinetic energy is a moving particle, that is half mv square. We have to take it into account. The total energy is nothing but summation of these two energy, that is kinetic energy and potential energy. Then force. Force is nothing but a push or pull acting on an object caused by interaction between the object. It can change, otherwise under the state of rest, motion or direction of motion. What are the characteristics means? You have to, whenever the force is applied to one particular body, you have to check the two characteristics. One is the magnitude and direction. That is important. SI unit is nothing but Newton. Formula according to the Newton's law. Force is equal to mass into acceleration. Then this slide gives a glimpse about the relationship between work, energy and forces. Work causes displacement. Displacement results in work. Force causes displacement. Displacement results in work. Work transfers energy. So here this is a mathematical relationship. Work is equal to F into D. We have a calculation, we have substitution over here. The various terms it is utilized here, that is the kinetic energy is implemented. The difference you are getting, the change in kinetic energy, finally you are getting. So in this, today we have seen the generalized coordinates, we have seen in robot force models, as well as we have seen about the generalized forces also. The two important topics we have seen for this week one. Students, I really thank you for your kind attention of this subject. It's a very easy subject as well as very interesting. In upcoming classes, we will see some few derivation part also. That is, as I already told in the syllabus, that is Newton law, Lagrange's equation, Euler's equation, various derivation part is there. So we will have a good discussion about in the various topics. So hope you understand this basic what I thought today. So we will see in the upcoming classes. Thank you all.